Hello, so today I'm going to be talking about tables. I'm going to give you some interesting stuff to keep things dynamic here. Again, the CL that I'm going to be going over in this video is strictly to give information back to the teacher dashboard. This video does not cover giving the students feedback, but I will cover that in another video. So let's get started. In this slide, students are given a line. They're also shown 2 points on the graph just to kind of help get them started if they need it. And in the table, they're asked to put down any 5 points that are on this line, and they should be different points. So to do this, because it's so wishy-washy on the student side, we don't know what they're going to type in, we have to really be flexible with our CL. For instance, we can't just assume that they're going to type in 10.5 as their first answer. If it were true, then in the CL, it would make it very easy for us to say the numeric value of that one should be 10, the numeric value of that one should be 5. So we kind of have to go off of the relationship instead and do some fancy work there. The relationship is that line, the equation of the line. So we know that the y, which is this side right here, is supposed to be equal to half of whatever the student types in as their x. And so if they type something like 8 in for their x, then they should get an answer of 4 over here. So what we want is when we go to the CL to say that we're going to use this equation, this expression, I should say, of the 1/2 x, and we're going to evaluate it at whatever number the student types in, which in this example that I used, it was 8, but whatever number the student types in. Then we're going to compare it to what they put on this side, which it should equal the y. So we're going to make these two things equal each other in the CL. And so I'm just going to copy this so that I can use it when I go to CL right here. And I'm going to define function f, like f of x. And I'm going to call it a simple function. And it has variable x. I'm going to check that f dot evaluate at, and I can evaluate it at any number, but I don't know what number the student is going to type in. So I don't want to say evaluate it at 0 because maybe they're not typing in 0 as their very first x. I want it to take exactly what the student types in. So that's going to be whatever they type in this component, the table. So I'm going to write this, and then they should be typing in a number. So cell numeric value of where is their answer located. It's in that first box, and I'll go back here just for a second. So I want to evaluate whatever they type in here. Remember before I was talking about if they type in 8, I want it to take half of 8. So whatever they type in here, which is box 11, cell 11, I want to take that and evaluate it. So if they type in 8, I should get 4 for whatever in so far. But what do I want to do with that 4 or whatever number it turns out to? I want to check if it's equal to, and this is my check statement, so this is a good time to check it. I want to see if it's equal to whatever they type in on the y side. Again, I don't know what they're typing in on the y side, so I don't want to just say like 5 here or 4 here or whatever. I want to like see what they type in. So that's going to be this cell numeric value of, and I have to be really careful, row 1, cell 2, so it's 1, 2. I frequently get these backwards. Sometimes like in this spot, I'll write 2, 1, and then I go to check it and things aren't working right. So watch out for that yourself. All right, so we can check if this is working properly by setting it equal to the correct sync. It's only going to check that very first row in the table, so we are not finished, but it should check that this works properly up here. And if it does, then it should mark it correct. So if I type in something and I take half of it and put half of it over here, it should mark it up here with a check mark, and it's not. So that's kind of weird, but did you notice that when I didn't have the 5 in there, that it was marking it as wrong? So that's like a good clue that something's working, but something's not. And this is something that I've mentioned a number of times before because it kept getting me when I was new. And that is that I have another component here that doesn't have any CL, and the computer's trying to check if that's correct, and it just doesn't know, so it says the teacher's got to look at this page. I don't know what to do. So let's tell it that we're going to read only that as true. Like, I don't want you to ever say that that's false or wrong. I want you to that's just a picture, really. So just mark it as true. So now if I go back and use 10.5 or some other value and then take half of it, it is giving us that check mark. But again, only the check mark for the first section of the table, and we want them to do more than this, so we have to go back and do more than that. We could put in something like 5, and this side should be half of that, 2.5, and it's working. So it's not dependent on exactly the number that I type in, but it's flexible with whatever number I type in. I should always put half of it over here, which is exactly what we want. So going back over here, this is sort of the magical spot right here, and we want to just sort of duplicate that. So we can say and this, and I'm going to go back and fix some of those values. All right, so I've got enough of them down, and I just have to be really careful about doing this properly. Okay, so this is row 2, column 1, so 3, 4, and 5. And then this is going to be 2, 2, 3, 2, 4, 2, and 5, 2. All right, hopefully I've done it correctly where we can check this off. Let's say that I do 2, 4, 6, 8, and 10. This will be 5, 4, 3, 2, and 1. And it works out that we get the check mark on the teacher dashboard. All right, let's jump ahead to another one that's very, very similar. In fact, it's so similar that let's copy this code and go to slide 7. Let's preview it real quick. So I want the students to be able to put answers in a table that fall on this line. So same idea, different line. And then there's some more to this. So let's just sort of stop there and put this down. Now, it's not the same line. It was x plus 2, I believe. So x plus 2 is simple enough that I can just write it that way, but you can always go back and insert the LaTeX if you need to. And let's see how this works just to start off. All right, so let's say that they say 0, 1, 2, 3, 4, and they add 2, 3, 4, 5, and 6. So again, we're getting that dot. That's because we haven't touched this graph, right? But if we get rid of the 6, we can see that x. So again, it seems to be working pretty well. We don't know for sure yet, but it's probably just because we haven't said read only true in the graph. So let's read the rest of this question because I kind of breezed past it and I want to make sure that we talk about that. Record 5 different points in the table below that fall on the given line. That part's done. Then it says the points that you enter into the table will automatically graph on the coordinate plane. So we haven't done that yet. So we need to do that. We also need to worry about getting the check mark here. Let's sort of concentrate on what I have highlighted first here. We want to take information from this table and get it onto the coordinate plane. There's a few different ways to do that, but in this case, the fastest way is to take all of column X and bring it over to the graph, and then take all of column Y and bring it over to the graph, and then graph the points that follow. So let's close out of here, and I'm going to show you how to insert that CL right now. So we're going over to the graph, and we're going to go into the CL for the graph, and we're going to say that we want to import a list. It's called number list, so if you just try L for list, it can be a little bit frustrating. So number list. And we want to import our X's first. And I need to give this list a name, and I'm importing all of my X's. So let's call it X sub all. If I do this, that means X sub 1. And that works fine in that situation. But if I have something like this where all is spelt with 3 digits, or 3 characters, I guess, then I need these wavy brackets around it. Same with like a double-digit number. So like if it was x sub 12, you would need the wavy brackets around the 12. But if it's just a single digit, you could get away without the wavy brackets. So we have to say, where is this number list coming from? So going back here, it's coming from our table, but I can't back here in the CL say this because this is the graph, but I want it to come from the table. So I really need a name for the table. So let's call it table, and then I'm going to name it table 7 because this is the table from slide 7. So now if we go back here, we can say table 7 dot, what do we want to pull? We want to pull the entire column numeric values, the entire column. And which column? We want to pull the first column, column 1. So that's going to take all of the values that are here for X. Sorry, it's not quite clicking. There we go. All of those, and it's going to bring them over to the graph. It doesn't tell it what to do with those yet, but it will take those numbers and bring them here to get ready to use them, and then we just have to say what to do with those. But let's import the Y's as well. So I'm just going to copy it and paste it, change this to the second column, which is the Y's, and call that Y all. All right, so what should we do with these? Now that we're getting all of the X's and all of the Y's, we want to actually plot them as points. So let's go into the graph, and points get plotted as X comma Y, but I named it the list X sub all and Y sub all. If you don't know this, on the keyboard to do this, which took me a while to learn, to get the subscript, you're going to do, like in this case, X, and then the sub is shift, and then the line that's next to the 0. So shift and line at the same time, and then type what you need. I'm not going to add sliders because these values are coming from the CL. If you do choose to add sliders, which you can, just make them like incredibly large so that it doesn't show up on the graph when you haven't even had student input yet. So here we go. Let's try this. Let's try 0, 1, 2, 3, and 4. Add 2 to it. So that's 2, 3, 4, 5, and 6. Beautiful. It's showing up really well. It seems to be working perfectly, except the whole point was to get that check mark. Why aren't we getting the check mark? Oh, right, because we haven't done anything with the graph in terms of is it correct or not. Well, if we set it up properly, it should always be correct. So let's not even worry about it. Let's just say read only true. Like, the student's not doing anything here. We're the ones that told it what to do. So we're just going to skip right over that and say read only true. It's not like we're checking what the student did. Over at the table, we're checking what the student did. And this works with any value. So we could do 2, 3, 4, 5, and 6. We could use negative numbers. And it'll continue to work, and we'll get the check mark if we have correct values over here. Now, if we mess up and say something like 610, then the entire thing marks as wrong, and you can see barely that point that doesn't fit with the others. So this is nice to give a little bit more feedback to the students so that they might be able to check their own work and adjust from there, if their values are within what they can see on the graph. Of course, that's always a thing too. All right, I'm going to stop the video here and make probably one more video for the last part of tables. Bye.